Good evening, everybody, and welcome to tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA meeting. So tonight, Mark Wilkinson is going to talk to us about a really cool tool called SQLTop. So please, Mark, take it away.
All right. Share my screen here. All right. Just let me know when you can see me.
Yep, screen is going.
Beautiful. All right. Well, welcome everybody. This is about SQLTop. The talk itself is writing your own CLI tools with PowerShell, a case study of SQLTop. I'm Mark Wilkinson. I'm a father of four living in Garner, North Carolina. I am a proud horse dad. My daughter has been riding and showing for about a year now, and I have recently started riding. And it is a fantastic departure from technology. Although I did speak with my instructor about maintaining a YouTube channel last time I was writing, so there is a little crossover. I'm also a Microsoft Data Platform MVP, co-host of the Mixed Extents podcast, as well as organizer of the 8KB SQL Server Internals Conference, engineering manager in DBA for my daytime job. And if you want to contact me for any reason, me at markw.dev. I have pretty much dropped off social media entirely, but I am always in my email, so feel free to send me an email, either related to this talk or really any PowerShell or SQL Server questions you may have. So the goal of today's talk is to inspire you to build your own tools and give you some methods maybe to make that easier. I learned a lot writing SQLTop, and hopefully some of the things I learned will be helpful for you. And this first part of this here hopefully will inspire you to build something. So, agenda today, why build tools? That's a very important question. A little bit about what SQLTop is, what it does. I'll give you a demo with some load running so you can see exactly how you might use it in your day-to-day. And then I'll go over some challenges and solutions that I encountered while building it. And then some closing thoughts. So first off, why build tools, right? So I broke it into 4 reasons. I'm sure there's probably more, but the first one, the tool that you want doesn't exist. This can be either the tool literally does not exist, or let's say you've got 3 or 4 systems that you need to kind of pull some data together and look at metrics from a couple systems, and there's not really a tool that does that. Maybe there's 4 tools, but the whole point of building stuff like this is to make your jobs easier. So the tool doesn't exist, or maybe there is a tool, but it's too complicated. Um, there's some like vendor monitoring systems, for example, that it has what you need, but it also has all kinds of stuff you don't need. It's super expensive, and it doesn't really justify paying for it or having it around just for this one little feature. So in cases like that, it might make sense to try to build that part yourself and see how you do. This third one is really important to me. Um, and I also happen to work somewhere that encourages this kind of behavior. But if you want a deeper understanding of a system or some sort of problem that you're encountering, sometimes building a tool to either investigate and or solve that problem is a really, really useful exercise. Not only for your own, make your own purposes to make your job easier, but it could also help everybody that you work with, through documentation or just using the tool that you built to either better troubleshoot something or understand why something's happening. And then finally, your external tool options are constrained. Um, this one, I'm thinking like financial companies, government agencies, where you might have some sort of restrictions on the types of things that you're allowed to install, things like that, or maybe there's not a lot of restrictions, but there's like a 6 month lead time before you can actually get something installed because it has to go through all of the the legal vetting and all that. So sometimes you're in a place where you literally can't install anything. So in that scenario, why would you not give it a crack yourself and try to build something? where I work, the first two are probably the biggest motivators for creating something ourselves. One good example is our solution that we use for trending performance data. There was a lot of vendor tools that you can use, but we really wanted to be able to look at production and development using the same tooling. And in order to do that with our exister, vendor supplied product, we would have had to pay, like $1,000 an instance per year times 600 instances. That quickly gets really, really expensive. So instead, I looked at some other options, and we ended up building something that costs a couple $1,000s a year and can monitor all of them and maintain data for 5 years. So we could look back 5 years and see how any server was performing. So that's an example I like to use because it's very obvious what the win there is. Other wins there, it's all open source software that's no longer maintained by me. I contributed to a project so that our monitoring would be a little better, and now that project is kind of ran off on its own. It's all community supported. If I do need any features, I can always put in a pull request. But there are ways to build tools and keep them maintained without having to put a lot of work into it yourself after it's initially built. By looking for open source projects that you can grab and modify things like that. But on to SQLTop. So SQLTop, um, if you're not in the Linux world, the term top might not be very familiar. So we're going to start there. Let me hop over here. So top is a tool in Linux and Linux-like systems. Let me increase my font size a little bit here. Sorry about this. To make sure everybody can see. Okay, so this is top. This is running on my laptop right now. Up at the top line here tells you how long the system has been up, how many users, just me, load average, tasks that are running, sleeping, big breakdown of different CPU percentages like user percentage, system percentage, waiting, what percent of time I'm waiting for IO operations. And then finally at the bottom here, it gives us a good summary of all of the processes that are running on my box. I can select these processes and kill them. There's a lot of different things that you can do in here, but it's a nice tool, gives you some, a good overview of what's going on in your system. There's its prettier cousin, HTOP. It's a little more colorful. I love colors, which you'll soon find out when you see SQLTop. This gives us a little more information like per core CPU usage, memory usage, swap usage, things like that. So again, a very useful tool that you would use on a daily basis if you're troubleshooting performance issues on a Linux server or something like that. So being a big Linux nerd and that I am, then I really enjoy tools like this, and I wanted something like that for SQL. The things that are available for SQL are things like the well-known who is active. That's a great procedure. I use it all the time still, but it's really great for finding out what's going on right now, this second. What I wanted is something that would refresh itself, much like Top did that I just showed you. So it would continuously, refresh itself and update itself, so I could track things and see what was going on. So that brings us to Top. So here's Top. There's SQLTop. It's running right now, pointing at a local instance, which obviously has no work running on it. So let me. I'm going to fire off a little test workload that hopefully does not cripple my computer. All right, that's firing off 40,000 different database transactions, just so I can give you a nice little visual here. So right off the bat, my doesn't like this font size, but we've got a bunch of different columns here of things that are happening. So the SPID, the session ID, the duration, block. This is if a session is being blocked by something. This is the session ID that'll show up over here. The status of the process, User and host name, which does not show up when I run this on localhost for reasons I don't yet know. The database it's connecting to, program name, all kinds of good stuff here. And you also notice we've got the color coding here. I colored every other line just to make it a little easier to follow with the eyes, but you'll notice something showing up in red every once in a while. Those are your lead blockers. So if anything is blocking but not being blocked, it'll show up in red. Actually, let me pause this for a second. You'll also see a little B that shows up there just to tell you that it's a lead blocker. Anything with an S is a system process. So that's just stuff running in the background. I specifically added that because we use Query Store, and we probably shouldn't, based on the size of our databases and the number of our databases. It's been a very painful process running Query Store, but it's finally running good. Thanks to a lot of hard work from a coworker of mine, Pablo. But regardless, when we run this against a server that has Query Store on it, and the Query Store processes are using a ton of CPU, that'll show up in here highlighted so that we can see it. Actually, while I have this paused, I'm going to actually drop this down a little bit because it doesn't like something there. Run that again. There we go. Didn't like that font size. So up at the top here, oh man, it's just going to give me a hard time today. There it is. Up at the top, it shows you the instance it's connected to, number of processes captured, how many of those are blocking. I swear I use this tool almost every day and it doesn't do this. So the demo gods are not being nice to me today. Wow, that's interesting. But anyways, it tells you last time the data on the screen was updated, how often it's updating, and then these two empty fields here. One of them is highlighted text, the other is the filtered process. So one nice thing that you can do, if you look kind of in the middle of the list here, you'll see something called warehouse, this process right in the middle there. If I'm trying to figure out what that process is doing, but it's hopping all over the screen like this, I can hit T. It'll ask me to type in some text. I'll type in warehouse. And now it's going to highlight that line for me and keep it at the top so that I can kind of watch what it's doing. There's other things you can do with highlighting. Like, let's say I want to look for everything being blocked by session 255 or 225. Whoops. Oh, hold on. My workload is complete. Usually it lasts a little bit longer than that. There we go. Let's fire it off again. All right, give it a second. There we go. Actually, I'll just I'll look for wait fors. Go back here. Wait for. So this is going to show me things that anything where wait for is the wait. It's not highlighting the blocked the lead blockers because I didn't want those highlighted because they're already highlighted in red. But you get the point. You can type in any text you want, and it will it'll highlight those lines. This is really cool for tracking wait types. If you're actually in wait type mode, which I'll show you here, if you go to M for mode and you hit W for waits, it'll give you a big list of of everything that's waiting here, including the wait resource. So one way that I use this screen in combination with some of the other features here is that if we're getting like page latch waits, for example, and it's all waiting on a specific resource, I can filter on that resource and it'll show me everything waiting on it. So like this key lock, I can hit T, type in key lock, and it'll highlight everything that's waiting on that. So this comes in handy when you're looking for, you're trying to filter on a program name or a specific database that's being impacted. Any number of things there. But all right, I may have overloaded my SQL server here. As you see up at the top there, it's telling me the query is taking longer than it should. I'm actually going to kill these processes down here and let it calm down. All right. Well, apparently I've broken my own server here.
That will happen.
That does happen. It happens often when I do demos. Wow. All right. That server is not in good shape. So while I'm doing this, there's a couple different modes that you can use in this program. You saw the wait mode. There's resource mode, which is the mode that we were originally in. There's a mode that will aggregate by procedure name, aggregate by program name, a bunch of different options in there. Let me restart this container real quick.
So
I
while
should
you're
say,
doing that, there was a question here where you've got queries taking longer than it should. Is there any, what's the context behind that? When does that appear?
ooh, so I'm actually going to have to look at my own code for that to answer that question. I'm going to bump this while I'm here because it's that's fine, I guess. So might actually have to dive into the code, but I'll find it. I'll find it when we do dive into the code because there's the section where I'm going to do that. But if the data refresh rate you see up at the top there is 5 seconds. If the query is consistently taking longer than 5 seconds, it's going to warn me about that. Just so that I know, so I'm not like staring at my screen that's not really updating and wondering why it's not updating. I don't know what happened here. It's not coming back. Let's try again. Huh. All right. Well, as usual, I've never had this happen. So yeah, we'll just scroll up and take a look at it, and I'll talk you through some other stuff in here. Which I really wish I could show you, but there's also an option to filter by specific session ID. That's the one I wanted to show you most because it allows you to track over time what is happening with that session, giving you a historical view of the weights it's encountered, CPU it's used, temp DB it's used, pretty much anything you'd want to know about it. Also gives you the option in that screen to kill the process or grab the query plan. I apologize. Let me close this out and just try one more time here. Is it? Actually, let me run top and just make sure it's not still running. Yeah, there's SQL Server in there. I'm gonna try one more time here. Mm. The server was there. It is possible that server is taking a long time to recover because I have been doing a ton of load testing on it. So we'll give it a break. We'll give it a little break. We'll go back. So that is as much as I can show you about SQLTop right now. Like I said, the server might just be going through recovery right now. I don't have any sort of maintenance tasks running on that, so the database might be might take a little while for it to recover. So we'll give it time to do that, and we'll continue on. Hey, demo, we covered that. All right, so challenges writing a tool like this. I broke it into a couple categories of challenges. System and environment quirks, some of which you got to see right now. Challenges on getting a nice smooth UI/UX. I am somewhat obsessed with the second one. I really think it's important when you design a tool that other people are going to be using. I apply that even when I'm the only one that's going to be using it, but regardless, if you're designing something that other people are going to be using, it's important to make it a nice experience that behaves how they expect it to behave. Otherwise, people just get frustrated and they don't use it. And then lastly, one of the challenges is keeping code organized. And by that, I mean keeping it maintainable. It's very easy to get carried away when you're working on a project like SQLTop. And you lift your head up a couple hours later and you've got a couple hundred lines of code that nobody else can read. So it's I tried to find small ways that I could kind of keep my code organized so that it wouldn't be a challenge to add features to or make little tweaks. So right into weird quirks. Embedded shells are really hard to work with. For example, read key, which is something that we'll look at a couple times today. Read key it's a way to capture a single character press off the keyboard. Does not work in ISE. SQLTop uses read key all the time. That's how you navigate the menu system. Um, VS Code has some quirks. The integrated console, which I'm sure if you've done a lot of work in VS Code, you've seen weird, strange things happening in there. And my solution to this is to just ignore this issue. um, that may not always be an option, but for SQLTop, it sure was. I didn't want to design it and try to work around the limitations of those products to make sure that this product worked inside of an embedded shell. So I expect people to just run it from the console. It might run in VS Code, but it might have some strange issues. So I erred on the side of simplicity, and I just ignore it. If you cannot do that, and you do want to, handle cases for different environments, there is a global variable in your PowerShell session called host. I don't have it specified as such on the screen, but I don't know if anybody here has ever used scoped variables, but the host variable, if you type $global host, this is your host variable. It's always available. But if you look at the name in host, this will tell you where it's running. So here, it'll say console host. Over in ISE, it'll say Visual Studio, or over in ISE, this is Visual Studio Code. I have the ISE color theme turned on, so I'm all confused and I'm thinking I'm in ISE. This is Visual Studio Code. And the host name will tell you that it's in Visual Studio Code. So if you do need to handle special situations, you can use that variable to figure out where you're at. I should say too that while preparing this, other quirks that I didn't talk about in this presentation, I did run into some new behavior and strange behavior related to PowerShell core. So I feel like at this point in the progression of PowerShell, it's a good idea to test your code in PowerShell core, or even develop in core and then test in Windows for for maximum compatibility. There are a few strange gotchas when you're going between the two. Like if you ever use the group object commandlet, which will take an object and group it by a specific property. In Windows PowerShell, it spits the data out in the same order it was in before it went into the group. In PowerShell core, it sorts it by that property. So if you are doing any sort of sorting and then piping something into group object, and then you push that code over to PowerShell core, all of a sudden your sorting is going to be screwed up. So there's some little things like that that you'll have to be aware of, I guess, when you're developing something for both types of PowerShell, be it core or Windows. So important to test on both. Invoke SQL command is trash. I say this jokingly. It's not actual trash. It's good. It's good stuff. I say this because I always have problems with it, but I still always use it, and I can only assume the reason I always use it is because it's good. But if you, like me, love using run spaces for absolutely everything, invoke SQL command is a nightmare to work with because it will randomly fail inside of a run space and cause all kinds of strange errors. It also, for whatever reason, defaults to error action continue. So if you have an error, it just continues on its merry way and doesn't actually stop the program execution. There is a you can set your error action preference at the top of your script to stop, to make sure all errors stop. But I don't typically do that. So if you're using invoke SQL command, just make sure to add error action stop at the end of it, to make sure that it actually stops execution when there's a SQL error. Back to the first slide about why I build, the first slide about building tools. Invoke SQL command is kind of complex for what I need for SQLTop. For SQLTop, I'm literally just running a simple query and pulling the results back and doing stuff with it. And for that, I'm just using .NET objects. So let's take a quick look here. This is the code for SQLTop. Oh, there we go. And as you can see in here, this is inside of a run space, which I'm not going to go into a whole lot right now, but we'll talk about run spaces in a little bit. And since I'm inside of a run space, invoke SQL command wasn't really working well. So instead, I'm just using .NET objects, which it's not that complicated to do. I've got a connection string, setting up a connection, using my connection string, opening the connection, creating a SQL command, and then I'm putting the command text here. I'm putting query, which is this big query I've got up here. This gets all the data that we need from SQL Server. And then I'm just stuffing all the data into something called dataset and pulling it out and putting it into results. So a little bit more complicated than SQL command, invoke SQL command, but this is rock solid. It works every time, and I have not had any issues with it. And once you write it once, you kind of remember all the objects you have to create, and it's not too bad. Now this isn't just about, this slide isn't just about invoke SQL command. This could apply to anything. Always remember that the .NET objects are there. So if there's anything built in that you're using, like invoke SQL command, any of those Microsoft provided commandlets that just aren't working or giving you strange errors, really think about, do I need this whole thing? Or do I just need a small piece of this that I need to use? And are there, is there some .NET code I could use that would let me, accomplish the same thing without all the baggage of this function? Flicker free, and then parentheses mostly redraw. I hate things that flicker on my screen. And I don't know, maybe some people will laugh that I have an entire slide and several pieces of example code about this, but I just hate it. I love when things look nice and smooth. It just, in my opinion, it lets the tool kind of get out of the way and lets you use it. If stuff's flickering and kind of moving around all randomly, it's hard to focus on what you're doing. So working towards getting things flicker free was an important part of this tool. And I used an approach that, this is one of those situations, which I'm sure everybody has had at some time in their career, where you think of this idea and you're like, wow, that's a really good idea. And then you realize, oh wait, I've heard about that somewhere. Oh yeah, this is something that was invented back in like the Nintendo days. It's super old technology and something that I had heard of and never really used before, and thought it was my own idea for a minute, but it wasn't. And what I'm referring to there is double buffering. So when you use clearhost in a loop for something like SQLTop, it creates this really horrible flicker on the screen that can get really obnoxious. Double buffering is it's an approach where you basically draw the screen inside of a buffer, inside of a variable, and then just write the whole variable to the screen at one time. And that's what we're doing. That's what I'm doing in SQLTop, and I've got some example code to show you that. But when you do this, it kind of bypasses all of the work that it has to do to process what you want to display on screen, and it just draws it because it's already stored in that variable. And I've got an example to illustrate that. But and then I'm just blanking the portions of the screen I want to write. If I've got a display that's 80 lines tall or something, but I'm only using 10 of them, I don't need to blank the whole screen. I can just blank those top 10 lines. So let's take a look at some example code. All right, so here I've got a basic, and we're going to be using this throughout the entire rest of the talk, this little get process function. If anybody's ever ran this, it's very much like top in Linux. Get process, give you a big dump of everything that's running on your system. There's a lot running on my system, as you can see, but we've got a few things about memory here, like what is this? Paging memory. We got CPU time, the process ID, and then the process name. So some basic information about what's running on your system. If you wanted to see a view of this that refreshed, much like top, you could run something like this. I do warn you, this is going to look like trash because it's supposed to. So what this does is it clears the host, which when I say clear host, you've got a big thing here, a bunch of text, you hit clear, you type clear host, clears the whole screen. That is surprisingly expensive to run, and you'll see in a second here. So I'm clearing host, and then I'm getting the processes, and I'm doing a little bit of sorting by CPU descending, just getting the top 10, and then I am sleeping for 200 milliseconds, and then I'm doing it again. So we'll run this, and that is really assaulting, right? Sure, it's showing you that the top CPU usage is whatever the heck isolated web container, maybe? It's probably actually this video stream. But you can see that the highest CPU usage is that process. But this is horrendous to look at. Nobody wants to look at that. I'll actually close that so you don't have to look at it anymore. Now let's compare it to this slightly more verbose method here. Look how beautiful that is. It's nice and smooth. And after staring at that other one for a few seconds, you can see how this one is it's nicer to look at. This is a tool you could spend some time in. So what am I doing different? I put the clear hosts in here just to get rid of anything that was on my screen initially. And then I am sitting in a loop while true. Be very careful, by the way. When you're running a loop like this, a while loop, while true, like if you're writing some new code and you type while true, the next thing you should type is start sleep. Just do yourself a favor and get into the habit of setting sleep on a while loop before you do anything else. Because if you don't, it's possible you could, just completely consume all the CPU resources on your box. Because if you just run while true, your computer is going to run while true as fast as it possibly can. So always add a little bit of sleep in there before you do anything else, before you add any other code in there, just so you don't forget. It's a great habit to get into and has definitely saved me a few times. And also, don't think like a human, think like a computer. 10 milliseconds, that's fine. Your computer's not going to lose its mind if it has 10 whole milliseconds to think about what it's going to do next. 10 milliseconds for a CPU is an eternity. So even just adding that small delay in a while loop like that is going to slow it down enough that it's not going to completely devour your computer. But anyways, what are we doing here? So I said before that we're using a concept known as double buffering. So this is the same, this chunk of text right here. It's the same thing we were using up here, up at the top. The only difference is that I'm putting it into a variable. All right. And then I am hiding the cursor. This console : it gives you a bunch of different, actually I'll show you. It gives you a few different things that you can do in your console. So : you hit tab for tab completion, all kinds of stuff in here. So you can get the the width of the window, the height of the window. You can set the window title. Like here's the title. What is it? No, not supported on this platform. Never mind. Yes, that is one of the things that is not supported in Visual Studio Code. And I do set a custom terminal title with SQLTop, so that is why I didn't use it. Anyways, um, if you are not in VS Code, you can actually set the title of the console, which is kind of cool. But one thing you can do too is you can set the cursor to be invisible. So you can do cursor visible equals false, and you'll see my cursor disappear. No cursor. Obviously, you would not want to operate like that on a regular basis, so we'll leave it at true. But when you're redrawing a screen, you do want to hide it. Because if we go back to this horrendous example at the top, you can see up at the top there, the cursor blinking into existence and then going away. Nobody wants to see that. So what I'm doing is I'm getting rid of the cursor. I am then using this special variable, the host variable, to reposition my cursor up to the very top left corner at 0, 0. Then, since I know that I'm going to be displaying 12 lines, because when I display when this is running, it's displaying the top 10 plus the 2 header lines. So I know I'm displaying 12 lines. So I create an array of spaces that is 12 times the width of the screen, which will be, all of this area here. After I get that, I do a console write, which blanks just the top portion of the screen, reposition my cursor at the top again, and then finally draw my output, which I captured up here. And then I make my cursor visible again in case there's a prompt or something that I want at the bottom. Now, like I said, this is all a lot of steps just to get rid of flicker. But once you know how to do it once, you don't have to learn it again. I can copy and paste this code all over the place, and I'll be all set for this method of reducing flicker. So this was actually a lot of fun. I'm the kind of person that if I get bored or I get stuck on a problem, I'll find something kind of strange like this to solve and work on it. So that was the outcome of this session of working on something strange. I figured out how to get rid of screen flickering. So we will close that. I'm going to check back in on SQLTop here and see if that is running. Oh my goodness. It is down for the count. That is bizarre. No worries. There's plenty of other stuff to talk about here. So moving on past the flickering screens, sharing data in state. This is a big slide, but another UI type thing, a very common practice that you may or may not have heard of, is separating the UI component from the data component. As a DBA or a database developer, you've probably been exposed to this concept. The idea behind this is that you don't want the UI, the user interface for the user, you don't want it waiting for the data to come in. You don't want to display a menu and then have it so that the user can't type anything until the data is done, populating on the screen. By separating these two components, the UI and the data, one, it makes everything a lot more maintainable because you've got two different places, two kind of isolated areas that you can that your code lives in. If you're having issues gathering data, you know that it's all going to be in that one spot. If there's something you got to edit the UI, it's all going to be in that one spot. You don't have to worry about breaking the data capture, adding a new button or something like that. But what that does is it breaking the two out, it allows you to do things like in SQLTop, you notice that it was saying that the query was taking too long, but we still had data on our screen. All the menus were still working, even though that query was stuck and it couldn't actually get the results that we needed. Everything else in the UI was still working fine. So that is a result of this thing I'm talking about here. So the way that I'm doing it in PowerShell is I'm using a run space. And if not to get too in the weeds about PowerShell, but when you're in a PowerShell console, you have a PowerShell session. The session has what's called a run space attached to it, and that's where all of your work is executing, is inside of that run space. You can manually create more run spaces, allowing you to run things in parallel. So you could spin up 10 run spaces and execute 10 different things at the same time. So what I'm doing with SQLTop is the data capture portion of it is running in a separate run space than the UI. So it's actually running in a separate process and then communicating back to the UI whenever it has new data. I'm doing this using something called synchronized data types. It allows me to define a variable in the UI code, and then pass that variable down to the data access code, and the two layers can communicate with each other via that layer. And as you'll find out, synchronized hash tables are almost magical, and I will show you why. So first, let's look at this. So this is just passing variables to a run space. And this example is just to show you how a run space doesn't have access to the variables in the session you're calling it from. So it'll make sense in a second. I'm going to create two hash tables. First, I'm going to clear this, create two hash tables. I'm going to add some data to each of them. One note on how magical hash tables are, if you haven't used them a lot before, this data property didn't exist until I assigned it. You can add as many properties as you want to a hash table just by assigning a value to it. You don't have to, add that property and then assign a value or anything. It just makes working with them, nice. So now I've got this run space hash. It has a property called data with a value called hello, and then I've got this one that's just called hash. Same deal. Now I am gonna create a script block here that adds the word world onto that data. Okay. I'm then going to create a run space. The interesting thing here is that I'm using this session state proxy to pass this run space hash into the run space. This makes that variable accessible from both the run space and the session, my console here that I'm accessing it from. All right, so I've got my run space created. It's open. I now have to create a PowerShell session for my script to run in and assign the run space to it. And then I'm going to run it. So the reason I am showing you this is to show you how the variable scoping works when you're using run spaces. So I've got this hash. The hash only, I got this hash variable here. It only exists in this console right here. Run space hash exists in this console, and then the child process that's running this little script block. So because it exists in both places, it will get world appended to it, while this one doesn't actually exist in the run space, so it's not going to get anything appended to it. So if we look at our results, you'll see that world got appended to the first one, which is this run space hash, and it did not get appended to that second one. And again, the reason I'm showing you that is just to kind of describe how you would pass data between, how I'm passing data between the data layer and the UI layer. I've got a little bit more complicated example I'll show you in a second here. Actually, right now. So this is a lot more complicated, but before you get too freaked out, this is mostly code that we saw in my other examples with a few extra pieces. So first off, we're creating now a synchronized hash table. This system.collections here, there's a bunch of different collection types that you can use. There's array list, bit array, there's hash table. So there's a queue, which I've actually used before, but in this case, we're just using a hash table, and we're specifying synchronized. Synchronized isn't specifically required for stuff like this, but what it does, what a synchronized collection is it's thread safe, meaning if my UI code and the data access code is accessing that variable at the same time, they don't have to worry about stepping on each other. There's controls built into that object to make sure that two things aren't writing to it at the same time. So I tend to, whenever I'm passing stuff between run spaces, I'll almost always use the synchronized type, just to make sure I don't run into any issues. All right, so we're going to create one called state data. For the most part, it's going to behave just like a normal hash table. So we're going to add has data to it. And if you look, it's now got something called has data that's set to false. The purpose of these variables will be obvious in a minute here. But so just like in our previous example with the simple hello world, I'm going to create a run space. I'm going to pass in that state data. I'm sorry. Sorry, my kids left their walkie-talkie on in this room, and somebody in the neighborhood is talking on it. So I thought someone was in here. Anyways, the joy of working in the kids' playroom. So I've got my run space created. I've passed in state data. This is the script block that's going to run, that's going to capture my data. So just like before, it's grabbing this, it's using this get process. It's going to get that. It's going to stuff it into this state data, that data that will be accessible to me from the UI part of this. And it's sitting in a while true. I've got my start sleep here so I don't smoke my computer. And what this will end up doing is every 2 seconds, it's going to grab the list of processes again and put it into this variable. And then it's going to set has data to true, letting the UI know that there's something to do. Letting it know that there's data that can be retrieved. So like before, I'll create a session. We'll add our script to it. If the run space code confuses you, it's because run spaces are confusing. Don't worry about it too much. There's a lot of really good blog posts about how to use run spaces. Just know whenever I'm talking about them that it's my way of running work in a separate process in parallel with what I'm doing in my main process. So now we've got our run space set up. We've got that script block in there. We've got this synchronized hash table that we're going to use to pass data between. Now we've got all of this horrible code that I showed you before to get that flicker-free refresh. We're doing a few different things here now too, though. If the state data is not there yet, we're just going to say waiting for data. And then we're also going to add an option so that you can press Q to quit. Which I will show you this code in another example later. So let's give this a run and see what happens. So here we go. Same kind of thing. It is refreshing every 2 seconds. And life is good. If the get process script block here, if that has an issue in the back end, it's not going to affect the UI at all. And what I mean by that is that I can hit Q at any time and it will immediately exit this application. It does not matter what is happening in the background. As soon as I hit Q, it will get out of there. Whoops, hold on. I'm using this stop variable to control my while loop. I just have to reset it so I can run it again. So yeah, the main reason for splitting these things up is so that this will continue to refresh, or if it freezes up in the back end for some reason, I can hit Q at any time, and it will just completely, quit out of what I was doing. I'm going to talk a little bit about user input in a few minutes here, and we'll go over kind of what this is doing here. Okay, so we talked about passing variables to run spaces, and then the real example of actually no, we didn't get to this one. Yeah, we did. Yeah, and how we pass data between the processes. And this is how I do stuff in. This is how I'm doing it in SQLTop. If we go all the way up to the top here, at the very top, I am setting up my state data. First thing I'm doing, and this state data is used for all kinds of stuff. It stores the instance it's connecting to because it needs to know that to connect. Last time the data was updated, how often it should be refreshing data, the current mode that we're in, if you want to reset the state of it, and some other flags are used, throughout for other things. But it's a really good way to communicate between processes. Okay, on to something a little lighter, pretty colors. Again, my UI obsession, you do need pretty colors. If for anything else, just to let people know that something is important, or that you need to look at this thing. Now, part of the trouble behind this is if you've got a big table of information like I display in SQLTop, it can be hard to figure out how to color it line by line. It's even harder to figure out how to color specific words, or in my case, even specific characters of words. So came up with a cheat. This is after I started doing the double buffering thing, where I just put everything into a big, I stuff the output of that function into a big variable. So what I do is I just treat the entire UI as one huge string, and with the help of a helper function called color, I'm able to parse through that big string and color what I want. So let me show you what that looks like. So I've got this function called color, and this is using something called Ansi escape codes. It is a set of special codes. See this nonsense down here on line 31. Um, do not for 1 minute believe that I know what all of that does by heart, because I do not. It's something I had to look up and figure out. But these special sets of codes here impact the color of the output on the screen. So since I don't ever want to type this ever again in my life, I wrote a function to do it for me. It is not following best practices because it is simply called color, but this is defined within SQLTop, so it's never ran by the user. So I don't need to use approved verbs like get color or set color or something like that. I'm just using it internally. But what this does is it takes some text, a foreground color, and a background color, and then outputs the text that you want in the colors you want. So let's get this function loaded. And now we'll do a little demo. So the way that we use it is write host, and then in this $ parentheses, we say color, hey, we want it to be green, folks. So when we see this, we'll say hey folks with a green hey. And there's there's all kinds of stuff you can do with this. Like if you want the quit button or the quit option in your menu to be red, you can just do something like this. Oops, quit. Oh my goodness, I can't type. Yeah, and now you've got a red Q, so you can see that in your menu. This has been a super handy function. I use it all the time. And you can use it for, like I'm doing here, coloring a single word. You can color a single character, or you could color an entire line, which I'm doing in SQLTop, and I'll show you that. Right there. Okay, so state data.results. That's actually where all of the output from that SQL query is stored. I'm doing some sorting on it and some formatting, but when I'm all done with that, I'm outputting it as a string and streaming it to a for each object. And then, so what I end up with at the end of that is that it's going over the output line by line. I use this counter here to determine if I'm an odd or an even row. And then I start using my color function. So this first one, if the filter is set, so remember when SQLTop was working at the beginning of the presentation, I was able to highlight text. Whatever I type into the text that I want to search for is stored in this filter variable. So if the filter is set and I'm not looking at a specific SPID, and the current line, this $_, the current line contains my filter word, then we want to make the color of the line black text on a white background. If it is an odd row, we want the text color to be cyan with a default background color. And if it's a even row with no other special attributes, then we just spit the text out directly. So that allows me to color anything that I want. When I get down here a little bit further when I'm drawing menus, right here, switch to weights. So the W is going to be green in that. Resource usage, the R is going to be green in that. And this is just a menu that's displayed in SQLTop. But with this small, helper function, I'm able to quickly, add some nice color and some pop to a lot of the the menus and things that I'm displaying in SQLTop. All right, we have 2 more slides. And this presentation is a little heavier than I thought it was going to be, so I hope everyone is sticking with me. Um, we're going to talk a little bit about user input now. This is an important topic, when you're talking about tools, because the users need to tell you what they want to do. The easiest one to use, obviously, is read host. I'm not sure if everyone has used read host before, but you can set a variable and then do read host, and set a nice little prompt. What do you want? And it'll display the question. The user types in their input, and it is stored in the variable t. So that's a very simple way to to grab user input from the user. But what if you're obsessed with user interface like I am, and you don't want them to have to press enter? Then what do you do? In that case, we go back to that global host variable, and there's a function called read key. It is a fantastic function. It reads a single key press. The only problem with read key is that it waits for you to press a key, so it blocks. Meaning, if I say host.ui.rawui.read key, it won't go past that line of text until you hit a key. But you can use it in conjunction with something called key available. Key available knows if your finger is currently pressing a key down. So if you sit in a loop and wait for key available and then grab the key, you're able to grab user input without blocking everything else that's going on. So again, in the case of SQLTop, where I've got a menu and I've got this constant stream of refreshing data, nothing has to block the user from pressing any keys. Nothing has to block that refresh of data because it's constantly monitoring to see if you're pressing a key. Another cool thing about the read key is you can capture any key. You can capture the escape key, capture F11, whatever key you want to capture. Obviously, all the letters and numbers and everything work as well, but it is kind of cool to be able to include, function keys and stuff in your tool. Just a thing to note: average key press for a human at the extremely low end is 50 milliseconds. I think the normal everyday user is probably closer to about 300 milliseconds. So if you keep your loops waiting for user input less than 50 milliseconds, you should always be able to pick up a key press. So I'm going to show you a little demo here of this one. So this is a couple demos in one here. So this first one, we're going to wait for a key press while doing stuff. This is to illustrate that if you use this key available, you're able to still do work even though you're waiting for the user to press a key without blocking anything. So what you'll see here is you'll see a bunch of dots start to go across the screen. And anytime I want to stop that, I can just press a key and it'll tell me what key I pushed. So I hit the letter D on my keyboard, which corresponds to virtual key code 68. This number will be useful in just a second. Why this here is important is, again, like I was saying with SQLTop, I don't want to have to wait for the user to press a key and pause everything else that's happening in the application. So if you include that key available in a while loop, you can do all the work that you need to do while still monitoring to see if the user is going to press a key. And this is just to illustrate, pressing literally any key you have on the keyboard. This little loop, and I would highly recommend. I don't know if I have all of this uploaded to my website, but I will by the end of the day. I highly recommend that people take a look at this piece of code and use it if you're going to start building interfaces like this. This is a nice little kind of chunk of code you can run that will let you figure out this virtual key code. Like I just hit the escape key, virtual key code 27, F11. Whoops, don't want to do that because that's full screen. We'll pick a different key, but yeah, no, letter Q. That's to quit. But if you run that code, it will it will let you figure out what the key codes are that are being used on your keyboard, so that you can map those to do specific things in your scripts. For example, since we know that the virtual key code for escape is 27, uh, down here I wired up a press escape to continue. All we're doing is we're reading a key, and while it's not equal to 27, while that virtual key code is not equal to 27, we're just writing this message over and over again. So if the user is pressing the wrong key, it'll just keep printing the message. As soon as they hit escape, it gets out. So if you want to, I think I started doing that in SQLTop escape to clear out of certain screens, but I switched back to Q. But if, for example, you wanted the user to be able to hit escape to cancel something they just did, you can capture escape with the read key. Another neat thing you can use read key for, since it does block execution, is you can use it to implement press any key, since that does not exist in PowerShell natively. So press any key to continue. Boom, pressed any key. I actually added press any key to continue to a internal tool that we use for database deployments, because I didn't want to force the users to have to press enter. Which I think a lot of the stuff I'm sharing with you all just kind of shows that maybe I've got some problems, but I like a nice user interface. That is user input. Okay, we've got one more slide and then a couple parting thoughts and maybe some more questions. So view definitions. When I'm talking about views, I'm talking about anybody that's seen a table style output in PowerShell. There's many different ways to control what that output looks like. I don't like spreading that kind of logic that controls what the UI looks like all over the place. So I had to find a way to kind of centralize it so it was easier to manage. And I'm pretty close to centralizing it with SQLTop. This sounds confusing. It may look confusing, but once you use it a few times, you'll understand it. But it's using a hash table of hash tables to store parameter splats of your options that we use for both sort object, select object, and format table. I'll show you in some demos so this makes sense. For those of you that aren't familiar with the term splats, I highly recommend doing a quick Google search and checking it out. It's a way that if you have, let's say you've got a function that takes like 5 or 6 parameters, but you don't want to, in your script or whatever that you're writing, maybe you've got a couple different cases where you have to call that function a few different ways. Splats allow you to define all of your parameters in a hash table and then pass the whole hash table to the function, and it'll fill out the parameters for you. It's really useful for doing like optional parameters that aren't always there and things like that. So I definitely recommend taking a look at that. Actually, let me let me do a little self promotion here. If you head over to markw.dev and you search for Splat, you'll see optional parameters with splatting in PowerShell. This post will go through exactly what splatting is and how you can use it. Here's an example with invoke SQL command. You just create a hash table with your parameter names in it and the values, and then pass it with the @ sign to the commandlet, and it will know to break that hash table out into individual parameters. So yeah, there's a lot of really neat stuff you can do with that. So I highly recommend checking out this post. I'll add it to this slide deck and make sure that everybody gets that. But back to the show here. So yeah, let me show you how I use that in SQLTop, and then I'll show you another demo. So in SQLTop, I have all of my sorting options and display options broken out into this huge hash table. So this is where the hash table starts. It's called display columns. The first key in the hash table is object tracking, and then these are the columns that are displayed for object tracking. Object, workers, blocks, CPU. These are calculated columns. This column will be named memory underscore megabytes. And all it's doing is formatting the megabyte number to look nicer on screen and aligning it to the right. Actually, that's what all of these are doing. Here's the weight stats one. So these are all the columns that are going to be in the weight stats view. The name is duration here because I am capturing the duration in seconds in my query, how long the wait has been occurring. And it will convert that into a nice date string. Or sorry, this is the duration that the process has been running, not how long it's been waiting. But regardless, this is how I'm defining all of the different columns that you see when you're using the tool. And then there's quite a few of them because there's a lot of different views that I wish I could show you. Um, and then there's also sorting options. So sort object, that function, you can pass it this information. So again, here's the weights view. It's this first expression is if you specify a text filter, it just makes sure that those pop up to the top. So if the filter is in our string, we set this to a 1, otherwise a 2. That'll make all of our filtered text bubble up to the top. And then we're sorting by something called group weight. That's for processes that have gone parallel. It'll aggregate all the weight numbers into a single value, specifically for sorting purposes. And then by the core that it's running on. But as you can see, there's a bunch of different sorting options based on what view you're in. This is a lot of text to look at, but it does make it really nice and easy to, I don't have to search around my code and figure out where I'm doing sorting and things like that. It's all right here. So let me show you a simpler demo than what we're using in SQLTop there. Okay, so let me clear this here. And let me show you I'm going to do the cooking show thing here, and I'm just going to show you the final output here. Okay, so this is the same thing we've been looking at, right? We're getting the process, we're sorting by CPU. I put this up here for my own purposes. Something was breaking earlier, driving me bananas. So I wanted to see how long it was taking to actually draw this screen. So I added that little counter there. But we also have a menu now. Press Q to quit, C to sort by CPU, T to sort by thread count. So if we hit T, everything changed, right? I did not apply any complicated formatting, so you'll see the CPU column kind of jump around when the digits after the decimal place get a little wide. But as you can see, it jumps right to this. It completely changes the layout. It's now sorting by the number of threads that the process is currently using. If I hit C, it jumps right back to the CPU, sorting by CPU again. So, it's showing you completely different columns. So how do we do that? Most of this code is from the other examples, so we don't really need to look at it. But this is what we're looking for here. So I've set the default sort to CPU. I've got a hash table called sorting options. If we're doing the threads view, we're going to sort by the thread count descending, then by the CPU. If you're in the CPU view, you're going to sort by CPU descending. And then for the display, if you are in the thread view, you're going to display the thread count, which is not an actual column. It's not a single column in the output normally, so we have to grab it. It's just a few objects deep. And then we're going to display the CPU, the process ID, and the name. One little caveat when you're using this, when you're defining the columns that you want to use for an output, you have to include all of the columns you want to display. So you see how the CPU seconds is nice. It's to 2 decimals. It's not doing what it does in this thread view where it's all of a sudden to like 7 decimals. That's because in this view, whoever wrote get process, they made the default really nicely formatted output. So when you interfere with that and say that I only want these certain columns, you're going to get these unformatted columns. So something to keep in mind if you are controlling output like that you will have to include absolutely every column that you want to view. You can't just simply put a star at the end here and have it display all the columns it would normally display. You have to know exactly what you want to display. And how we're using this, I've got my little menu down here. So like I was saying before, I'm seeing if there's a key available. If there is, I'll read the key and I'll grab the character. If it's a Q, I'm going to stop, which will break out of this loop here. I'm also going to clean up my extra session in my run space that I created. If it's C, it's going to set sort to CPU. It's going to set a flag called redraw, and then it's going to clear the host. For threads, same thing. It's going to set sort to threads, redraw to true, and clear the host. When sort is set, what it's doing is up here, sort object, property, sort options.sort. What that does is if sort equals CPU, it's going to use this to define the sort. If it's threads, it's going to use this to define the sort. And then I'm selecting the first 10 like we have been. And then I'm using format table and doing the same thing here, display options.sort. So again, for threads, it'll do display option dot threads, and it will just pass this to that function, allowing you to display just those, just those fields. So yeah, that is a good way to kind of centralize that kind of stuff. If you're going to be doing a lot of sorting, not yet implemented, but I'm also working on dynamic sorting, so the user can input any column and it will sort by that. But yeah, that's a good way to have those kind of pre-canned views in there for it. All right, a few final thoughts. I know that was a lot. Thanks for everyone that has stuck with me so far here. PowerShell+.net is super powerful. You saw me in my code using a lot of .NET, and it's just because it gives me a lot, finer control over how things are working, and it gives you access to a lot of stuff you wouldn't have access to via normal commandlets. You can, hopefully, you've taken away that you can also coerce PowerShell into creating some nice looking UIs. With a few tricks, and always remember run spaces have more than one use. On my blog, markw.dev, I've got a few examples of how to use run spaces that folks should check out. It's like I said, earlier, it can be a little bit intimidating, but once you get a pattern to using them that works for you, you won't know how you lived without them. So definitely check that out. And then finally, most of your admin scripts are already written in PowerShell, so why not add a UI? And that is it for me. Thank you very much, everybody. Like I said before, feel free to email me at markw.dev. My GitHub is there, github.com/m82labs. For reasons that are beyond me, I did not put my blog on here, but it is also at markw.dev. So be sure to check that out.
Well, that makes it easy to reach out to Mark if you need to. In the meantime, if there are any questions from chat, let's have Adam. And I think you got to the one about the query taking longer than it should.
Yeah. I don't know exactly where the code is for that, but yeah, essentially, if the query is taking longer than the amount of time, it has that default refresh rate of 5 seconds. So every 5 seconds, it'll run that query and pull the results back. If your query is taking longer than 5 seconds to run, it's gonna tell you about it, just so you know why your data is not refreshing.
Yep. So that way you don't look at it and say, "Oh, everything's going great. I haven't had anything show up on here in a while."
Exactly.
Okay, looks like everybody's saying great job. I agree, great job.
Thank you.
So with that, if there are no other questions, then we are going to wrap up for this evening. Thank you again, Mark. We certainly appreciate you taking the time to talk to us about building a CLI.
Thanks for having me.
SQLTop. Of course. So next week, everybody, we are going to be back here next Tuesday, our main meeting. You can get all of the details at meetup.com/trypass. Until then, everyone, take care.